guys. Today we are solving systems of equations algebraically again, specifically using our elimination method. Today's problems will be just a little bit more intense, not quite so obvious on how to eliminate, but just pretty much the same as yesterday. There's going to be like one extra step at the very beginning, otherwise not too bad. Here's our first example. As a quick reminder, your equations must be in standard form. If they are not in standard form, you will need to change them so that they are in standard form. I can tell by glancing at these equations that one of them is not in standard form. I can tell this because there's like extra stuff over here. Not everything is lining up nicely. Specifically, I mean the x's and the y's and the numbers are, but the equal signs are not lined up nicely. And so I will need to change the second equation by subtracting the 9 to the other side. Now, I didn't change anything about the first equation, but I did just, rewrite them somewhere else so that I could see now very clearly that they are both in standard form, and I'm ready to try to eliminate. If you remember from yesterday's video, for elimination, we need one of the variables to have the same coefficient, but with different signs. And the only way we're allowed to alter an equation is through multiplication. Looking at my variables, there's not an easy way to make them both the same number. For my letter x's, I have a 3 and a 5. Those are both prime numbers, so I can't make a 3 into a 5, and I can't make a 5 into a 3 through multiplication. Same thing with my y's. I've got a 2 and a 3, which are both prime, and so I can't turn a 2 into a 3 or a 3 into a 2. And so when that happens, when you can't change one into the other, you're going to have to multiply both equations until they both have the same number. In this problem, you can choose to eliminate the x or the y. Either way, you'll have to multiply both equations. I'm going to choose to eliminate the y, and I'll tell you my reasoning. Not only do we need to have the same numbers, but we also need to have opposite signs. And looking at my initial equations, I already have opposite signs for my letter y. One of them is already negative, and the other one is positive. And so I just need to change the numbers, and I don't need to worry about changing the signs. And so that's why I'm going to try to get the y's to eliminate. So next you need to think of, it's called the least common multiple. You need to think of the smallest number that a 2 and a 3 can both turn into using only multiplication, and that number is 6. So I'm going to try to make both my letter y's have a 6 in front of them. And so for the top equation, to change a 2 into a 6, I'm going to multiply that whole thing by 3. And for the bottom equation, to change a 3 into a 6, I'm going to multiply that whole thing by 2. Now, again, I've already got opposite signs. The top one is negative, the bottom one is positive, and so I don't need to change the signs. I just need to change the numbers. Don't forget, when you're multiplying all 3 numbers. Okay, don't forget to distribute to all 3 numbers. That's probably the most common error made on these problems, is forgetting to multiply one of the numbers, and then everything just falls apart after that. So be very aware of your multiplication. All right, so I've got my new equations over here. The y's cancel, which is what I wanted to happen, and everything else we're just adding together. So 9 plus 10 is 19, and 18 plus a negative 18, or 18 minus 18, since it is negative, is 0. Now you do need to write the number 0 there. You can't just leave that side empty. You do need to write a number on that side, and the number is 0. Next, I'll be dividing both sides by 19, and 0 divided by anything is still 0. So my first answer is x equals 0. Now that is a totally legitimate and fine answer to get. It's okay to get the number 0 as an answer. It doesn't mean it's a special case. We'll talk about special cases in the next video. Okay, don't forget that once you have your first answer, you are not done. So don't stop here. Keep going. You're going to take that x equals 0, and you're going to substitute it into one of the, we have like 5 equations we could choose from. We could choose from one of the originals. We have this new equation down here, or we have these new equations over here. I wouldn't use the new equations that you got after multiplying because the numbers are bigger, which makes it a little bit trickier. And you might have made a mistake when you were multiplying, and so those might get you the wrong answer. I would choose from one of the originals. Again, it doesn't matter which one you choose. It should give you the same answer from both of them regardless. I chose this one because the numbers were just a teeny tiny bit smaller. If you don't like working with negatives, maybe you want to choose the second one. All right, so I'm going to plug a 0 into that x, and then I get that y equals -3. And then don't forget your final answer needs to be written as an ordered pair. And so my final answer is 0, -3. The x goes first, the y goes second, alphabetical order. All right, for our next problem, I'd like you to try it on your own. You can make your own choice about which variable you want to eliminate. And then for your second step, you can do substitution. You don't have to do elimination for the second step. So go ahead and pause the video and try this problem. All right, I hope that you paused and got an answer. I'm going to help you out a little bit just to check and make sure that your elimination part went correctly. So I'm going to actually show you how to eliminate both variables in case you chose X or Y. That way you can check your answer for either or. If you chose to eliminate the Y's for the same reason that we did on the previous one, they're already a positive and a negative, and so we don't have to change the signs, then you should have multiplied the first one by 3 and the second one by 2. And when you're done multiplying, this is what you should have gotten. So check and make sure that you got the same numbers as I did. So a 15, a -6, and a -57, and then a 4, a 6, and a 0. Now, if you instead decided to eliminate your x's, totally fine. Great way to solve this problem. You can change a 5 and a 2 both into a 10. The one thing you do have to be careful about if you're changing your x's is, they're both positive right now, so you will need to make one of them negative. It doesn't matter which one you make negative, and you just make it negative by, instead of multiplying by a number, you multiply by a negative number. So I chose to multiply the first one by 2. 2 times 5 would give me a positive 10. And then if this is going to turn into a positive 10, I need this to turn into a negative 10. So I multiplied the second one by -5. Now you also could have multiplied the top one by -2 and the bottom one by +5, and you still would have gotten the right answer. Here's what I got after I multiplied and distributed. So make sure again that you're distributing to everything. You get a 10, a 4, and a 38, and then a -10, a -15, and anything times 0 is still 0. So if you chose to eliminate your x's, hopefully you got this. And let's check that final answer, which is an ordered pair, -3, 2. This concludes our elimination video.